Hey guys, welcome back to my channel. We're going to do video 2 on functions. So you should now have had a recap on all that you need to know about function notation and why we're using functions. I just need to make a quick clarification on the difference between sketching and plotting. Okay, when you are asked to plot a graph, you will typically have to draw a table of values, work out the exact coordinates, and then maybe fill out the numbers. So 2, 2, I'm just making these up, 6, 4. And then you might then have to connect the curve up. Well, you will usually have to connect the curve up to make the shape of the graph. If you're asked to sketch a graph, you're not going to be required to do all of this. So all you need to do is a rough shape and then label the key points. So for example, that might be 0, 0. You might cross where it crosses the y-axis or the x-axis. And that's the main thing we're looking for. So for example, you might get a quadratic where if this is your sketch, you might then need to label, well, this must be 2, 0. This will be -2, 0. This might be -4, 0, -4. So this would suffice as a sketch. It doesn't matter that you're not using a ruler or you're not doing any scales on the axes or anything like that. Okay, so topic overview. We've looked at function notation and why we use it with graphs. I'm now going to show you these two things here. So vertical and horizontal translations, why and how they work, as well as reflections. So let's look at one example here. So what I have here is a function. So the function is f of x equals x squared. I've kept it simple for the purposes of demonstrating here. Now let's say we need to fill out this graph. So I'm going to color code it. I'm going to keep the original graph black as I do it here. So I'm just going to square each of these x values. I can see -3 squared is 9, 4, 1, 0, 1, 4. You can plot those points here. So 0 squared, 1 squared, 2 squared, 3 squared, and 4 squared. And I'll do the same thing on this side. 1 squared, 2 squared, -3 squared is +9, and -4 squared is 16. And then I'm just going to connect all the points up. This might not be very neat because I'm on a computer. So that's my graph, f of x equals x squared plotted. Now let's see what happens when I do the same graph, but that the function has been changed to f of x plus 2. So I've added 2 here. So that just means f of x plus 2, well, f of x, I know what f of x is. F of x is x squared. So essentially, I'm plotting x squared plus 2. So let's work out a few values. -2 squared is 4. 4 plus 2 is 6. -1 squared is 1 plus 2 is 3. This is going to be 2. 1 squared is 1 plus 2 is 3. 2 squared is 4 plus 2 is 6. You can see some symmetry here. And if I start plotting these points, I end up with 0, 2. 1 goes to 3. 2 goes to 6. 3 squared is 9, plus 2 is 11, so that's going to go up to 11. And you can see something has happened here. I'm just going to plot the rest of the points. And if I connect these all up together in a lovely smooth line, you can see the graph has just shifted up by 2 units. All of the values here have just gone up. And let's see what happens, and this time I'll use a green pen, when I subtract 2. You can probably predict what's going to happen here. So I'm just going to fill out this table. So I can see it's going to be f of x minus 2. Now f of x is just x squared, so x squared minus 2. So I get 0 squared minus 2 is going to be negative 2. 1 squared minus 2 is negative 1. 2 squared is 4. 4 minus 2 is 2. Okay, so I've filled out the table here. And I'm going to plot the points and we'll see what happens. I can assume that you predicted it's going to go down by 2 units. So it's 0, negative 2. 1 is going to be negative 1. 2 will be 2. And you can see this does indeed what happens here. So 3 will go to 7. And then you end up with a plot of, and each of these values is about 2 units. Well, it is exactly 2 units below the black line. So you can see why we use function notation. We can kind of simplify these transformations here. So let's look at what happens if we have the same function here. So f of x equals x squared. F of x plus 1, we know that's going to move up by 1 unit. What happens when you have a plus 1 inside the bracket? We'll come to that. First, I'm just going to skip ahead a tiny bit. I'm going to plot this graph in black, and I'm going to plot this graph in red. Okay, so I've plotted the two graphs. They're a tiny bit messy because I'm on a computer here, but you can see the red line has shifted up by 1 unit. Now we're going to look at what happens inside the bracket. So since you've done a recap on functions already, you should know that to work out what's happening here, we're going to put x plus 1 as a replacement for that x in there. So if f of x equals x squared, which is what we're given, then f of x plus 1 will equal x plus 1 all squared, and that becomes x plus 1 double brackets. Now, you can expand it, or you can just leave it as x plus 1 all squared. And then you can work out the values without having to expand it. Although if you do want to expand it, you can. It just makes it longer to do it that way. So you have your x values given to you in this graph. So for example here, negative 4 plus 1 is negative 3. Negative 3 squared is positive 9. So let's plot that here. So let's see what happens. So where x is negative 4, y is 9. So that will go there. Now let's try negative 3 plus 1 is negative 2. Negative 2 squared is 4. So then negative 3 goes to 4. Then we can see negative 2 plus 1 is negative 1. Negative 1 squared is 1. Then we have negative 1 plus 1 is 0. 0 squared is 0. And so you get 0 here. So that's interesting. So that black curve goes to 0 on the origin, while this green curve goes to 0 on negative 1. 0 plus 1 is 1. 1 squared is 1. So that's going to be the same point as the red graph. And then we have 1 plus 1 is 2. 2 squared is 4. So that will be 1, 4. And then we have 2 plus 1 is 3. 3 squared is 9. So that will go up here. And then you may notice what's happened. 3 plus 1 is 4. 4 squared is 16. So the graph looks like it's actually shifted in that direction. So it's moved to the left compared to the original black graph. So inside the bracket it seems to move it left or right, but it moved to the left even though we added 1. Well, we're going to look a bit more into that in the next part here. So let's just plot this again. So I'm going to pause the video for myself and I'm going to plot this graph and this graph. And then we're going to see what happens when you do x plus 1 and x minus 2. Okay, so I've listed the values for the function f of x plus 1. We're going to plot this and see what happens. So negative 4 goes to 9, so that's going to be up there. Negative 3 goes to 4. Negative 2 goes to 1. Negative 1 goes to 0. So we can actually see it's been shifted 1 unit to the left from what we can see here. All of these coordinates have just moved 1 unit. Let's just finish this off. So 0 goes to 1, and 1 goes to 4. You can see that quite clearly. It's just a shift of 1 unit in each case. And then we have 2 goes to 9, 3 goes to 16, and so on. And we can just finish off the curve here. So that graph has shifted 1 unit to the left. Let's see what happens when we do x to the power x minus 2, f of x minus 2. Well, that just means x minus 2 all squared. So negative 4 minus 2 will give you negative 6. Negative 6 squared is not going to fit on this graph, so we'll leave that one out for now. But we can just we'll fill out the table anyway. Negative 3 minus 2 is negative 5. Negative 5 squared is not going to fit there as well either. Negative 2 minus 2 is negative 4. Negative 4 squared is 16, so we can get that in there. Negative 1 minus 2 is negative 3, so negative 3 squared is 9. So that's going to go here. Negative 2 squared is 4. Right, let's plot that one again. I think I've accidentally plotted that one wrong. So negative 2 goes to 16, so that is going to be up here. Negative 1 goes to 9. 0 goes to 4. 1 minus 2 is negative 1. Negative 1 squared is just going to be 1, so 1 goes to 1. 2, take away 2 is 0. 0 is 2 is just going to be 0. So it does look kind of out of place so far, but actually we're spotting if that's the minimum point of this graph, it's going to start to go up again here. So 3 minus 2 is 1. 1 squared is 1, so that will just go to 1. And then we can actually see for 4, it's going to be 4 minus 2 is 2. 2 squared is 4, so it goes up. And you can see actually the shape makes sense because it's gone this way. So when you have minus 2 in the brackets, it happens to have shifted. If you look at just the black line and the green line, it shifted 2 units to the right. So from that, we can actually draw a few conclusions here. So inside the bracket seems to shift the graphs left and right in the opposite way that you think they would go, and outside of the brackets. So for example, here, we've shifted it up or down. So it's a vertical translation. We're going to actually use a bit of Desmos. I can hear you guys cheering. So this link will be in the Google Classroom. I'm going to show you how you can use Desmos. I'm going to just do that on a slightly separate part here. I'm going to show you Desmos in the part 2 of this video here.